Hello everyone, this is Vishwa, and today we are going to see about basics in probability and statistics for analytics. The first slide is about the basic definitions. The first definition is random experiment. Random experiment will have unknown result and different outcomes. It must have different outcomes and we should not know the result will be. Sample space is a set of all possible events where event is a subset of sample space. Probability it's like possibility. Some people call it as probability. Probability is defined as favorable events to total possible events. It's like possibility percentage as well. Union is something called its add operation denoted as U, like U1 intersection union U2. That is everything from both E1 and E2. Whereas intersection is a kind of multiplication. Typically it is as AND operation. It is denoted inverted U, like E1 intersection E2, which means common things between E1 and E2. Discrete events and continuous events. An event which has discrete events means individual outcomes, whereas in continuous events the event will have the event is like range x, where x ranges from 2 to 6. That means x will have all the values between 2 and 6, like 3, 4, 5. Continuous, we will discuss about discrete in third chapter and continuous in fourth chapter. Venn diagrams, it is a graphical method to represent sets. For example, A, it represents all the possible outcomes will lies inside the circle, whereas B will lies all total possible events will lies in between the circle. Like this is the area which is sharing by A and B, which means A intersection B. Now this is A or B, that means A union B. Everything from A as well as B. For example, this is a sample space having 3 different events A, B, C. The common area shared by all these 3 events is A intersection B intersection C. The area, this blue color, is like area is sharing A union B, and also intersected with C. Okay, and this area, this green color area, is B intersection C, but it doesn't have A, that is minus A. Next, multiplication rule. The multiplication rule is defined as if A can do in m ways, B can do in n ways, when A and B do together in m into n ways. That is, for example, A tossing a coin, B throwing a die, A and B together will give head 1, head 2, head 3, head 4, head 6, as well as T1, T2, T6. That is 2 into 6, 12 ways. Combination. Combination is a rule of counting where we selected all objects out of n objects. Here, the order is not important. The basic formula NCR equals to n factorial divided by n minus r factorial into r factorial. The key terms here are selection, order is not important. Next rule of counting is permutation. Here, arranging all objects out of n objects. Here, order plays a major role. We should understand the problem whether he is asking the selection or arranging. Permutation NPR equals to n factorial by n minus r factorial. We can write it as like this as well. There is something called circular permutation. Circular permutation is arranging objects in a circular format. Here we are fixing any one of the position. For example, I am fixing A. I am arranging the remaining. So because of fixing one position, we are minus 1 factorial. Circular permutation, number of circular permutations of A, B, C, for example, A, B, C, D, E, F is 6 minus 1 factorial, that is 5 factorial ways we can arrange A, B, C, D, E, F in a circular format. Number of possible of arranging n objects in a line where P of one kind, Q of another kind, and R of one kind. So arranging of same kind is n factorial divided by P factorial into Q factorial into R factorial. Here, for example, boy, another boy, same kind, is because of same kind we can arrange them as it doesn't affect the arrangement. So that's why we are dividing the same kind. This is a note point. Tossing a coin n times or tossing n coins at a time will give 2 power n ways total in 2 power n ways. For example, if we throw a coin in 3 times or 3 coins will throw at a time, 2 power 3, that is equals to 8 ways. As well, die throwing n times or throwing n dice at a time will give 6 power n ways, that equals to For example, if you throw a die for 2 times, it will give 6 square ways, that is 36 ways, like 1 comma 1, 1 comma 2, and so on, 1 comma 6, 2 comma 1, 2 comma 2, and so on, 2 comma 6, 6 comma 1, 6 comma 2, and so on, 6 comma 6. At least meaning is minimum. It will start with that number. P of x equals to 1, 2, and so on. At sometimes it is very difficult to find out all possible ways. We are just eliminating from one, like P of x greater than or equals to 1 is equals to 1 minus P of x less than 1, that equals to P of 1, P of x equals to 0, 1 minus. At most means maximum. It will stop at this point from 0, 1, 2, 3, 4. Now let's see some problems. Find the number of arrangements a word Mississippi, number of possible arrangements. There are 11 letters here. Out of 11, 4 are same kind, yes, 4 i's and 2 p's, that is 4 factorial into 4 factorial into 2 factorial. A die rolled 2 times, that means total outcomes is 6 square, that is 36 ways. This is the total possible ways. As I said earlier, 1 comma 1, 1 comma 2, and so on, 2 comma 1, 2 comma 2, and so on, 2 comma 6, 1 comma 6, 6 comma 1, 6 comma 2, and so on, 6 comma 6. There are 36 ways. Same phase is appear. That means how many are there? The possible 1 comma 1, 2 comma 2, and so on, 6 comma. There are 6 possible outcomes out of 36, that is 1 by 6. Sum is 10. What are the possible ways? 5 comma 5, 6 comma 4, 4 comma 6. That's it. That is, there are 3 possible ways out of 36. That is 1 comma 12. Here it is an interesting question. Sum is neither 8 or 9. We have lot of ways like 2, 3, 4, 5. So it is difficult to find out. So we can write it as 1 minus P of sum 8 or either 8 or 9. That is 1 minus P of sum equals to 8 and P of sum equals to or 9. I have a shortcut which will give sum of dice throwing 2 times. Sum, the black will show the sum, the red will show probability. For example, sum is 7, we will get 6 possible ways like 3 comma 4, 4 comma 3, 6 comma 1, 1 comma 6, 2 comma 5, 5 comma 6. Reducing 7, 6, 5, 4, 3, 2. 2 is the minimum, like 1 comma 1 is the minimum number of minimum sum. 1, 2, 3, 4, 5, 6. Likewise 8, 9, 10, 11, 12. Like 5, 4, 3, 2, 1. 12 is the maximum sum. For example, I need sum 4, sum equals to 4, probability. What is the corresponding number? 3 divided by 36. For example, 8. P of sum equals to 8, that is 4 by 36. Next question. For a website design, there are 4 colors, 3 fonts, and 3 images. Here, what rule will apply? Multiplication rule. According to multiplication rule, 4 colors, and 3 colors and 3 images will give 36 ways of designing a website. The fourth, the printed circuit has 8 different locations. Okay, 8 different locations. Out of 4 different components are placed at a board. So out of 8, there are 8 locations. We are taking 4. We are taking 4. Here the keyword is if arrangement, as well as order also is important. Order is important. So we'll go with permutation. 8p4. 8 factorial by 8 minus 4 factorial. Okay, it will give 1680 ways. Problem number 5. In a hospital, operating room needs to schedule 3 knee surgeries, 2 hip surgeries. Total how many? 5. That is 5 factorial ways in total. Out of 5 factorial, 3 are same kind, 2 are same kind. So that's why we are dividing 3 and 2 will give 10 ways. This is an interesting question. A bin of 50 parts contains 3 defectives. A bin has 50 parts. Out of 50, 3 are defective, 47 are non-defective or undefective. So non-defective. Out of 3, the first question. This is the question without replacement. Here we are not replacing. Make sure that it is without replacement. How many samples of size 6 contains 2 defective parts? Here we are selecting 2 from 3 defective parts. So out of 3, we are selecting. That's why we use combination 3C2 ways. If 2 selected from 50, one after another, find the number of ways of selection. One should be defective, another should be non-defective. Here, for example, if in the first condition, I'll take non-defective, then I should take defective. Or first I take defective and non-defective. So non-defective how many? 47C 1 into 3C1, or 3C1 into 47C1. Total 282 ways. That's it. The total number of one defective and another defective is 282 ways. That's it from today's class, and we will figure out the next axioms, conditional probability in future classes. Thank you so much.